Numbers, functions, infinity, imaginary numbers. At first glance, mathematics feels like a collection of unrelated ideas. But what if I told you there exists one tiny equation, just a few symbols long, that somehow connects the five most important numbers in mathematics, and not randomly, but in a way so elegant that mathematicians often call it the most beautiful equation ever written, to the power of IPI plus 1 equals 0. This is Euler's identity, a small equation, yet somehow it connects nothingness, identity, growth, circles, and imaginary dimensions. But why is this equation considered mathematical perfection? To understand that, we first need to meet the genius behind it. Meet Leonhard Euler, born in 1707, and honestly, calling him good at math would be a massive understatement. Euler was one of the greatest mathematicians in history. Many symbols we casually use today became popular because of him. Things like f of x for functions, the symbol pi in modern mathematics, and even e, the mysterious number behind exponential growth. He transformed fields like calculus, mechanics, graph theory, number theory, and astronomy. And here's the unbelievable part. Euler continued producing groundbreaking mathematics, even after becoming nearly blind. That's the level of genius we're talking about. And among all his discoveries, one equation stood above the rest. Now, if you look at Euler's identity for the first time, it almost feels random. Why do these symbols belong together? Let's break it apart. First, 0, the number of nothingness. Without 0, modern mathematics and computers wouldn't exist. Then comes 1, the identity number, the beginning of counting, simple yet fundamental. Then there's pi, the mysterious number hidden inside every circle. No matter how large or small a circle becomes, the same ratio always appears, 3.14159, forever. Then comes e, a strange number that quietly appears everywhere in nature: population growth, radioactive decay, compound interest, physics. In many ways, e is nature's favorite number for change, and finally, the strangest character of them all. I equals the square root of -1, a number whose square equals -1. At first, mathematicians thought imaginary numbers were nonsense, impossible, because how can a number multiplied by itself ever become negative? But eventually, people realized something shocking. Imaginary numbers turned out to be essential for electricity, engineering, signal processing, and quantum mechanics. So somehow, Euler managed to combine nothing, identity, growth, circles, and imaginary dimensions into one equation. But how? This is where things become beautiful. Most people think exponents mean growth, like 2 squared becomes 4, 2 cubed becomes 8, 2 to the power of 4 becomes 16. Bigger exponent, bigger number. Simple. But Euler discovered something completely unexpected. When exponentials meet imaginary numbers, they stop growing, and instead, they begin to rotate. Imagine standing at the center of a circle, moving around its edge. 1 full turn equals 2 pi. Then Euler discovered this astonishing formula: I to the power of ix equals cosine of x plus I sine of x. And this formula says something incredible. Imaginary exponentials create circles. Think about that. An exponential function, something normally linked with growth, suddenly transforms into rotation. Straight lines become circles. Real numbers connect to imaginary worlds. Growth becomes motion. Now here comes the magical part. What happens if we replace x with pi? We get e to the power of I pi equals cosine of pi plus I sine of pi. Now evaluate it. Cosine of pi equals -1. Sine of pi equals 0. So the equation becomes e to the power of I pi equals -1. Move the -1 to the other side, and suddenly we arrive at e to the power of I pi plus 1 equals 0. And there it is. The equation that feels almost too perfect to be accidental. But mathematical beauty isn't just about looking elegant. Euler's identity is beautiful because it says so much with so little. Just five constants, no unnecessary complexity. Yet somehow, it connects. Arithmetic, geometry, algebra, calculus, and complex numbers all at once. For many people, the moment they truly understand Euler's identity, math stops feeling random and starts feeling like a hidden language underneath reality itself. Because the deeper science goes, the more often this equation quietly appears in waves, in electricity, in signal processing, in quantum mechanics, almost as if nature itself speaks mathematics. And here's something strange to think about. Nobody invented these relationships. Humans discovered them. Pi already existed before circles were drawn. E already existed before banks calculated interest. And Euler's identity, it was always there, hidden quietly in reality, waiting to be discovered. So here's the question. Did humans create math?